Electric potential derivation. In this video, we are going to derive the formula for electric potential. Today's lesson is going to be a bit mathematical, but we'll try to simplify it as much as we can. So let's get started. But before we start, do not forget to hit the like and subscribe button so that you'll be the first to watch our next video. Now, as we discussed in the earlier video, an electric potential is the amount of work done in bringing a unit test charge from infinity to a point. So we need to quantify this, so that we can calculate the electric potential of any point. Let's say W external is the work done in bringing a Q naught charge from infinity to a point P. Now the potential of a point P is equal to W external by Q naught. But to calculate work done at infinity is not possible. Because at infinity, electric force becomes zero. So the integration of electric force becomes zero. So now what to do? Since the electrostatic force is conservative in nature, so the amount of work done in bringing a charge from infinity to a point P is equal and negative of work done in sending a charge from point P to infinity. Meaning, let's say, if 100 joules of work is needed to bring a charge from infinity to a point P, then minus 100 joules of work is needed to send the charge from point P to infinity. So we can calculate the work done from point P to infinity, and then assign a minus sign, and we get the value of electric potential. Let's do the calculations this way. Let's say we have a charge, Q, and there is another charge, Q naught, at a distance r. Now the electric force at this point is Fe is equal to K into Q naught divided by r square. The external force and this Fe are equal and opposite in nature, so that there is no gain in kinetic energy, and the balance is maintained. So, therefore, F external is equal to K into Q naught divided by r square. Now, since the force is dependent on the distance, so it's variable. And for the variable force, work done is equal to integration F dot dr, from r to infinity, where dr is a small distance. Putting the value of F in the integration, we get integration r to infinity, K into Q naught divided by r square, into dr, into cos 180 degrees. Since the angle between F external and dr is 180 degrees. All the terms are constant, except r, so 1 by r square remains inside integration. Upon integrating, we get work done is equal to minus K, Q into Q naught, divided by r. Now, since work done in bringing the charge from infinity to this point is negative of this value, we get work done, infinity to P, is K, Q into Q naught, divided by r. And the potential of a point, P is equal to this value divided by Q naught. So, Vp is equal to Kq by r. So this is how we write the potential of any point. Remember, the sign of charge Q is also taken into the account. This is it for today's video. Click the next video to continue learning. Also, do not forget to check the exclusive offers, link in the bio.